Hello, ladies and gentlemen, and welcome back. Root Beer here with more of the 2000 Cayley paper. We are on question number 12. Natural numbers are equally spaced around a circle in the order from 1 to n. I'm guessing we're going to have to figure out what n is. If the number 5 is directly opposite the number 14, then n is... Okay, good question. So, we have numbers, and they're spaced around the circle in order from 1 to n. So, questions to ask. Are there particular n's where you can have numbers across from other numbers? And if so, when you do that, what's the relationship between n and the difference between numbers opposite each other? So I don't know the answers to these questions. I mean, maybe you do, but I don't, and I'm trying to solve the question. So, in absence of any other information to go on, I'm going to look at smaller cases and see if I can notice patterns that I can then extrapolate and say, oh, we have this relationship between opposite numbers spaced around the circle, and from there we can deduce n. Okay, so we're going to look at some examples. We'll make them short. So we'll draw a circle here, and then maybe we'll do like 4 examples. So this first one, it'll be 1, 2, 3. Let's make it interesting. So if we space them out equally, nobody's opposite 1 or 2 or 3. So 1 to 3 certainly didn't give us anything opposite. How about 1 to 4? 1, 2, 3, 4. We have, per the instructions of the question, we have the numbers 1 to n spaced evenly about the circle. And we see that 4 is opposite 2 and 1 is opposite 3. And so immediately I can see something like, the difference here is 2. Okay. How about 5? 1, 2, 3, 4, 5. And I see that no one is opposite 1, no one's opposite 3, no one's opposite 2, and no one's opposite 5, and no one's opposite 4. So I'm thinking that odd n if n is an odd number, then no number in the circle will have something opposite each other, something opposite it. So let's try 6. 1, 2, 3, 4, 5, 6. And I see, hey, 6 is opposite 3, 4 is opposite 1, and 5 is opposite 2. And the difference is 3. And up here the difference was 2. So with odd ones we don't seem to get anything, and with even ones the difference between one number and its opposite seems to be half of the total number of numbers. So let's try this with a bigger example. Let's try 10. So first we'll write down our claim for an even number of n, so an even n value. Opposites differ by n over 2, which is going to be a whole number because we assumed n was even. So let's try it for, let's say, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wouldn't you know it, 10 is opposite 5, 1 is opposite 6. So it looks like this is indeed working, and if we know that, then we can take a look at the case we're given. So the information we're given is we're given a circle, and it goes 1, 2, 3, 4, 5, and it just keeps going around and around, and then it goes all the way up to n. But we know 14 is opposite 5. This is information we are given. 13, 15. Now, since some numbers are opposite to others, since we have opposites, n is even. And let's just take a look. So 14, 16, 18, 20. So we can immediately rule out b is 15. If there were more odd numbers, we could rule out even more and then maybe take a guess if we couldn't finish the question. But the value of n, we know, is twice the difference of opposite numbers. Well, we have a pair of opposite numbers. 14 and 5 is 9. So n is 2 times 9, which is 18. And I think that was E, but let's just double check. No, it was D. My apologies. And something we could do if we wanted to is we could go back and say, okay, if n is 18, what does this actual circle look like? And then we could write it out and verify, hey, yeah, 5 is opposite 14. We don't need to, because the math speaks for itself, but if we had the time, if we were a little unsure, we could actually draw out the circle and put 1 to 18 around the circle evenly and see that, yeah, this is true. Okay? I'm not going to do that. If you're curious to see what it looks like, by all means write it out for yourself, but I would much rather spend my time moving on and taking a look at question 13. And that's exactly what I'm going to do in the next video. So thank you guys so much for watching. Feel free to like the video, and I'll see you guys for question number 13 next time.